Hello, today I'm going to talk about inner product. Inner product is basically a multiplication on a vector space. If I ask you to do a multiplication on a real number, that would be a piece of cake like 2 times 3 equal to 6. What if I ask you to do a multiplication on a vector space? And of course, here we use Rn. And a vector space not necessarily be a real number, but let's assume this is a real number to make it simple. Actually, there's several ways to do a multiplication on a vector space, like a cross product and inner product here. And inner product is also known as the dot product and the scalar product. They are basically the same thing: inner product, dot product, and scalar product. So if we have a vector space here, then we will have some vector. We will denote this as x belongs to Rn. That means that x equal to this one, x1, xn. X becomes n dimension numbers. So we denote the inner product in this way. X, the inner product of x and y will becomes x dot y, and that's why we call it a dot product. And transpose of x times y. The formula is the summation I from 1 to n xi yi. Here we'll get a scalar, and that's why we call it scalar product. That means we will not get a vector here after the operation. Let me show you an example, like x equal to 1, 2, 3, y equal to 4, 5, 6. So the inner product between x and y will become 1 times 4, 1 times 4 plus 2 times 5, 2 times 5 plus 3 times 6, 3 times 6, and that's it. That's the inner product. Here we'll get a number here like 4 plus 10 plus 18. This is 32. Here we'll get a scalar. This is not a vector. That's very important. What if we do the inner product again itself? Basically we'll get the square of the norm. Actually is a Euclidean norm. Then the vector space become a normed vector space. Is a very important concept in mathematics, and indeed this norm is the square, the norm of x is the length of vector x in n dimension. And sometimes we will have some vectors pairs. The inner product of x and y will become 0. Here we will call them they are orthogonal. What does it mean? Basically is in geometry we will call it perpendicular. So if there's two-dimensional vectors, we will have something like this one and this one. These two vectors are perpendicular, so the inner product becomes 0. If we are in a three-dimensional space, these vectors are perpendicular, so the inner product will also become 0. And thank you, and that's it.